This is a very complicated device, but I'm going to try and explain it to you this way. So this is free to swivel. And now I just want to point out, it's not perfect, but this indicator rod should be directly below there. Can you see that at all?
Yeah.
Now let's get that radius here to the center. Okay, so go ahead. It looks like it's somewhere between 17 and 18 to the center of the axle. Okay, yeah. You can decide, maybe 17.3, I don't know. Now, when I connect this spring on here, there's too much tension for it to hang purely vertical. So what I'm going to do is, I already set this up in advance, so I figure about 900 grams should work. So let's just check. What I mean by work is, if I put this 900 gram mass on here and hang it, and let it come to equilibrium, it's not perfect, but it should be approximately directly over the indicator rod. As such, we know that this mass, 900 grams times G, should be equivalent to this force, whatever that spring force is. You can, in theory, figure out the spring constant, how much it's stretched, but really all we need is the force. What we know is that if this mass is above that indicator rod, the only way that's possible is if this spring has a force which is equivalent to the weight associated with this mass of 900 grams. Whoa, that's a lot of words. Now I'm going to take this off of here. And I'm going to spin it. I'm going to get it going here. And obviously, if it's going at just the right speed, I think it's going a little too fast now, right?
Yep.
So notice the mass is beyond the indicator rod. But when it gets close, I'm going to try and time it. Tell me when it's right over, or close to it, a little on the outside. Is it getting close?
It's getting closer, but it's still a little bit out, I think.
Okay. So we're just going to do one shot here, so we're going to have to be patient. Notice it's pretty low friction. Is it getting closer?
Getting there now, yeah.
Okay. So let me get in here, underneath here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoops. So I got about 8 seconds for 10 revolutions. Let's try one more. Just so we got this all. We'll confirm. So we want to start with it slightly outside and end with it slightly inside. Is that over it? A little bit outside?
Yeah.
I'm going to get under here.
About now, yeah?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that time I got about 7.32 seconds for 10.
I think that's a better number myself.
Yep. So probably somewhere in that range. Again, that was for 10 orbits. This one's probably the better number. Let's trust that one.
All right.